Have you ever wondered where everything came from? The vastness of space, the twinkling stars, the planets orbiting in their celestial dance. I mean everything. The stars, planets, even you and me. All of it has an origin story that is as fascinating as it is mind-boggling. Hi, this is Rumela from Awakening Sci-Fi Stories, presenting you the story of cosmic creation. It all started with a bang. A really, really big one called the Big Bang. This event set the stage for everything we see around us today. Imagine all the stuff in the universe crammed into a space smaller than a pinhead. It's almost impossible to fathom, but that's how it all began. Then, boom, everything exploded outwards and started expanding. This expansion continues even now, billions of years later. This wasn't an explosion like fireworks, though. It was a much more profound event. It was more like the fabric of space itself stretching and growing, creating the vast cosmos we are part of. In those first moments, the universe was unbelievably hot and dense. Temperatures and pressures were beyond anything we can experience on Earth. Like a giant pressure cooker, but instead of cooking soup, it cooked up the very first ingredients of our universe. These ingredients are the building blocks of everything we know. We call this process Bigbang Nucleosynthesis, and it's the amazing story of how the first elements were born. Hydrogen, helium, and a bit of lithium emerged from this cosmic cauldron. Buckle up, we're about to embark on a journey through time and space, exploring the origins of our universe. Picture the early universe as the hottest soup imaginable. I'm talking trillions of degrees, hotter than the sun's core. At these extreme temperatures, matter couldn't exist as we know it. Atoms with their protons, neutrons, and electrons? Nope. Instead, everything was a chaotic sea of energy and tiny particles zipping around at incredible speeds. It was so hot and dense that particles were constantly colliding with each other. These weren't just any collisions, they were powerful enough to smash particles together and create new ones. Think of it like a cosmic billiards game, but with much higher stakes. Remember those tiny particles? Two of the most important ones were protons and neutrons. Protons carry a positive charge, like the positive end of a battery, while neutrons are neutral, like Switzerland. In the early universe's extreme heat, protons and neutrons were constantly bumping into each other, sometimes sticking together. But here's where it gets really interesting. When protons and neutrons collide with enough energy, they can fuse together, like tiny drops of water merging into a larger one. This process releases a tremendous amount of energy, making the early universe even hotter and more chaotic. What were the first elements to emerge? As the universe expanded, it also began to cool down, like a pot of soup taken off the stove. This cooling process was essential for the next steps in the cosmic evolution. This cooling was crucial because it allowed those fused protons and neutrons to stay together and form the very first atomic nuclei, the hearts of atoms. Without this cooling, the universe would have remained a chaotic soup of particles. The first element to form was the simplest and most abundant in the universe, hydrogen, with just one proton in its nucleus. Hydrogen became the building block for more complex elements. Next came helium, with 2 protons and 2 neutrons, followed by tiny amounts of lithium and beryllium. These elements were formed in the first few minutes after the Big Bang. These were the only elements forged in the Big Bang's fiery furnace. The creation of these elements set the stage for the formation of stars and galaxies, leading to the universe we know today. Then, out of the fire, the journey went into the stars. After about 3 minutes, the universe had cooled enough that Big Bang nucleosynthesis came to an end. This was a crucial moment in the history of the cosmos. The universe was now a vast expanse of mostly hydrogen and helium gas, sprinkled with those trace amounts of lithium and beryllium. These elements were the first building blocks of matter. But this wasn't the end of the story, not even close. The universe was just beginning its journey of transformation and complexity. These simple elements, forged in the Big Bang's heat, were the building blocks for everything else in the universe. They set the stage for the formation of more complex structures. Gravity gradually pulled these gases together, forming giant clouds that eventually collapsed under their own weight. This process took millions of years, but it was essential for the next steps in cosmic evolution. The intense pressure and heat at the centers of these collapsing clouds ignited the first stars, where nuclear fusion continued, creating heavier elements like carbon, oxygen, and iron. These stars would eventually explode in supernova, spreading these elements across the universe, seeding future generations of stars and planets. So, from where we get our cosmic origins, the very atoms that make up your body, the air you breathe, and the ground you walk on were all created in the Big Bang's incredible furnace. We are all made of star stuff, connected to the universe's earliest moments. Understanding Big Bang nucleosynthesis helps us unravel the mysteries of our cosmic origins. It's a testament to the power of physics and the interconnectedness of everything in the universe. From the tiniest particles to the largest galaxies, we're all part of this grand cosmic story. Thank you for being the part of this cosmic journey. Stay tuned for more such space stories.